So this second calculator example might look a little shorter. It's actually a little bit more difficult as we get to the calculator. You might see that, but the first step would be to type that function into the calculator as a y equals. So you go to y1 and you type in your equation into y equals. So I'll go to my calculator and do that first. X to the fourth minus 4x squared. Get to your graph. So you notice on this one, it looks like a W sort of. You've got 3 x-intercepts, it appears. You've got 3 places where it touches or crosses the x-axis. So remember, those are either called your x-intercepts or your zeros. So let's start with those. So I'm going to push second trace. I'm going to go to 0. I like to go from left to right. So move it to the left of there, move it back to the right. Don't need to guess. That appears to be a -2, and it is. So I'll write that down on the answer sheet in a second. I don't normally do this, but let's go and find this one. Just confirm it's a +2. It looks like a +2. Yep, it is. Okay, now the middle is the one I want to mention more about. This appears to be the origin, and it's going to depend sort of on how old your calculator is. We'll see what this calculator spits out. So this one gives me an error. So that is a limitation of the calculator sometimes, okay? I mean, it appears to be the origin, but we can confirm that. It's just that your calculator won't do it for you. So we did have 2 answers for sure. X-intercepts, we had a -2. We also had a +2, and we think the other one is the origin. So this is how you can confirm it. Well, you do have to think back to stuff we've done earlier this year. So what you can do is factor this expression. Can factor this expression, f of x equals x squared times x squared minus 4. And then this factoring it one more step would give you this expression. Well, that just confirms what we suspected. This 0 is a -2. We already got that over there. This one is a +2. We already got that. And this one would be a 0. Because if we put a 0 in here, this would cause the entire expression to become 0. So the third answer, which we kind of knew off the calculator, is the origin, is a 0. But again, you can confirm these things without a calculator by just doing the algebra. So the calculator does have some limitations sometimes. So the x-intercepts are done. The y-intercept, well, we've already done that actually. The y-intercept on this one happens to be the same as our origin, right? So our origin is, it's calculator. Our origin is special. It's both the x-intercept and the y-intercept. It's the place where the graph is crossing the y-axis. So our y-intercept is done. We already did it. We already did it up there. The zeros are also already done. x equals -2, x equals +2, x equals 0. And again, those come from your answers from part A. You just rewrite it in a different notation, basically. That's all it is. So that brings us down to part D, the turning points. And again, you know, we've kind of already confirmed one of them. I'm fairly confident that one of the turning points is the origin. But we'll go back to the calculator to confirm these things. It looks like there are 3 turning points. There's 2 minimum values and this maximum value in the middle. So again, we're going to go, I like to go from left to right. So let's do the minimum. Left bound, right bound stuff. -1.41, comma -4. Go back and write that. -1.41, comma -4. The other one looks like it's just symmetric with that, so second calc, do the other min, left bound, right bound. Yeah, so it's just symmetric with that. It's the positive 1.41, comma -4. Now the one that I'm suspicious about is this origin. I mean, we already sort of confirmed it, but I'm going to go back to the calculator and see what the calculator tells us. So that would be a max. The left bound of that max, the right bound of that max. So I just want to see what this calculator gives me. So on this one, I'm getting this weird answer down here where it says max is -1.378 e to the -6. Y is -1.59 e to the -12. Well, that's the calculator doing the best it can. It's just estimating. So you have to remember that you're going to round those off to zeros. That's scientific notation. So again, the calculator is just estimating the best it can, but this is the answer you want to write. So when you get a weird expression like that on your calculator, just round it off to 0.